Welcome to the video presentation for group project for CS5513. The project title is Extending the Existing Data Migration Algorithm for MySQL to MongoDB and Analyzing its Performance. In this presentation, we will be going through the introduction related work where we talk about existing algorithm used for the data migration. Then moving on to the proposed work where the extension made in the algorithm will be discussed. Further on, we will talk about results followed by conclusion and future work. Introduction. The relational database being popular currently has a lot of drawbacks when it comes to the big data. The size of data is increasing exponentially and hence it becomes difficult for relational database to handle such dramatic increase in the data, which is known as big data problem. Another problem in relational database is that it cannot handle unstructured data. Since the current business decision making involves processing and analyzing large volume of data, the migration of data from relational to NoSQL becomes important. Objective. The main objective of this project is to implement existing algorithm for data migration from MySQL to MongoDB and then extend the existing algorithm to improve the performance based on time taken for data migration and the query processing time. Finally, graphical representation of the performance metrics will be shown. Related work. MongoDB provides flexibility in storing data and retrieving results. The time for inserting, updating and retrieving records in the MongoDB will be less than that of the time taken in the relational database. This work in the reference paper motivated us to compare the results generated from the MongoDB with MySQL. Before moving on to the algorithm, I'll execute both the algorithm This is the first algorithm which I'll be talking about. Which is implemented in Python. This is the second algorithm. This is also implemented in Python. This is a flowchart of the existing algorithm. First, the algorithm will get the connection established to the MySQL database and get table names. If a table has foreign keys and reference tables, then the table record with the referential constraint will be fetched to the cursor. If it doesn't have any foreign keys, just the table record will be fetched to the cursor. The user will specify structure mode. There are two structure modes. One is linking mode and the other is embedded mode. The MongoDB collections will be created based on the given structure mode. As I said, there are two modes in the existing algorithm. One is linking and the other is embedding. So now I'll talk about the example of linking and embedding. This is the example for linking. The table orders has foreign key employee ID. So while creating collection in the MongoDB, the collection orders will be linked to the employee collection based on the employee ID. And coming to the embedding example, since the order ID is a foreign key in order items and employee ID is a foreign key in orders, or the orders and order items are said to be child record of the table employee. So the record in the order items and orders will be embedded into the employee's collection. There are few drawbacks in the existing algorithm, like the user have to explicitly choose between the linking and embedding mode. The second is when linking mode is chosen, it will result in many collections in the MongoDB. Suppose if we give a query which should access more than one table, then there must be a join operation between two or more tables, which is said to be cost inefficient. And when we go for embedded mode, more child records will be embedded into the same parent record, which makes one collection to be very large and the other collections which doesn't have any foreign key to be small. Hence we went to extend the existing algorithm. This is the flowchart of the extended algorithm. The flow of the program is the same except for this block. Like, instead of getting more explicitly from the user, we extended the algorithm based on 6 conditions. Here the user need not specify the structure mode explicitly. Rather, the program itself, based on the 6 condition, choose whether the table has to be migrated in linking or embedded mode. Coming on to the 6 conditions. The first condition is if the table does not have any referred tables, a new MongoDB collection will be created for that particular table in MongoDB. If a table has a parent key but no foreign key, then also new collection will be created in MongoDB. Third condition, if the table has one foreign key and one parent key, then we use linking. This is the same example of linking which we saw in previous slides. And the fourth condition is if a table has one foreign key and no parent key, then we go for one-way embedding. Like, for example, here the table salary has foreign key employee number, but it does not have any parent key. So the record of the salary table will be embedded into the record of employee table in MongoDB. That is, the record salary is embedded as a array of document in employee collection. Fifth condition is two-way embedding. Whenever a table has two foreign key and no parent key, then we go for two-way embedding. Here, the department employee table has two foreign keys, one department number and the other is employee number. So the record in this department employee table will be embedded to departments as well as employee. You can see an example here. The record of department employee table is embedded into the employee collection as well as department collection. Suppose if we have more than two foreign keys, the same procedure is repeated with multi-way embedding. Here is a general example for our second algorithm. Like, by implementing the first algorithm, we got 6 collections if we used linking mode, and we got 2 collections if we used embedded mode. But in this, if we use this algorithm, 3 collections will be created. Based on condition 1, since the employees table does not have any foreign key, so the collection for employees is created separately. And it's the same case with expenses table. Even it does not have any foreign key, so the collection for expenses is created separately. And the table orders has one parent key and one foreign key. Like, this is a parent key, employee ID is a foreign key. So for orders, it will follow linking. That is, orders is linked to the employees collection based on employee ID. And the table order items has just one foreign key and no parent key. So the entire record of this child record will be embedded into the parent table orders. You can see here there is an array of objects named order items into the collection orders. So this totally gives 3 collections. For implementing the both algorithms, we used Python, MongoDB version 3.6.2 and MySQL version 5.7.18. To test the data migration from MySQL to MongoDB, we took a dataset which contained approximately 3 million records. It was obtained from MySQL official site. This is a description of our dataset and schema of our relational database. Here are the screenshots for creating relations in MySQL. Now I'll go and show you the tables that were created in MySQL. These are the tables into which our data set was loaded. Both the programs are still executing. So I'll go on with the further slides. This is a screenshot of our first algorithm. Since it used linking mode, it created 6 collections. It had 6 tables in the MySQL, so we ended up in creating 6 collections in MongoDB. This is a screenshot for the second algorithm. This list shows the referenced tables. That is, department manager is referencing the employees and the departments table. Department M table is referencing both employees and departments tables. Titles is referencing just the employees table. Salaries is referencing just the employees table. So based on the 6 conditions, we just displayed which table will be created based on which condition. Since the department M table is referenced by employees and departments, it will have a two-way embedding to employees and departments. Since the departments and the employees table does not referred by any other table, so they both go in second condition. And the department manager is referenced by employees and departments tables, so even it will follow two-way embedding to employees and departments. The title and salaries just refer the employees table, so they go with one-way embedding to employees. This second algorithm will create just 2 collections for the corresponding relation from the MySQL. To test the correctness of the migration, we just used few queries and checked whether they all return the same results. We performed found the number of departments with department number D001 on MySQL database. It returned 20,211 records. The same query was given in MongoDB collection, which was created by existing algorithm. We got the same number of records, and we got the same number of records when we queried the MongoDB collection, which was generated using the second algorithm. And this is the example of one more query which we used for testing the correctness of the data migration. Let me go and check whether the collections are created. Still running, executing. For plotting the graphical results, we used select query, join query and group by query on MySQL and the MongoDB collections created by both the existing algorithm and the extended algorithm. We got the processing time for each of the queries and plotted graph. So this is the graph which shows the query's execution time. The blue is for MySQL database, the orange one is for existing algorithm and the gray one is for extended algorithm. The query 1 is select query, query 2 is join, and the query 3 is for group by group. Here are some of the range queries which we used to get the performance metrics, and we recorded the processing time for each of the queries and again plotted a graph. So irrespective of the query, the time taken by the query to execute in MySQL was always higher than that of the time taken for the query to be executed in MongoDB collection, which was created by algorithm 1. And further, the time taken for the query execution in algorithm 2 was less than the other two. This is a data size comparison chart. When we stored the approximately 3 million records in MySQL, it had 142.8 MB data size, whereas in MongoDB collection, which was created using algorithm 1, took 1046.9 MB of data size, and it was 375.2 MB data size for the MongoDB collection that was created using algorithm 2. Let me check with the program execution. The first algorithm is almost in its completing stage. Like we can see, it created 1, 2, 3, 4 connections successfully, and the second algorithm is on its way in creating the first connection. So we can conclude that the data size has always been large with the linking method which we used in algorithm 1, and the query execution time reduced on combining the linking mode with the embedding mode. That is in the second algorithm, where we used 6 conditions to decide whether to go with linking or embedding. For this project, we just converted the MySQL database to MongoDB. This can be still more extended by generalizing for all relational database like Oracle and so on. And the efficiency was measured by just testing the algorithm with one data set. So we can measure the efficiency by testing the same algorithm with varying data sizes. These are the references which we used in this PowerPoint. I can show you the program execution result once they are done. Now the body program has executed successfully. Now I'm going to show that the collections has been created in the MongoDB. The old employees database is the one created using the first algorithm. Like see, it has 6 collections, and the new employees database was created using the second algorithm. It has just 2 collections. Now I'm going to show you the correctness of the data migration. I'm going to execute this query in MySQL. This query will return the count of the department number with D001. It has 20,211 records. let me check the same query with MongoDB collection that was created using algorithm 1. I have to use that database. Yeah, it returned the same 20,211 records. I'll show you with the collection which was created using the second algorithm. It also has 20,211 records with the department number D001. This is the second query which we use to check the correctness in the data migration. So the employee number is 0001. The first 5 records of the salary of the employee with employee number 1001. I'll execute the corresponding query for the collection that was created using the first algorithm. You can see these were the 5 records which we got when we queried on MySQL database. Let me now do the same query on the collections that was created using the second algorithm. So you can see these were the 5 records that was displayed when I queried with the MySQL database. These were the screenshots of the output which I showed now. So with this, we are at the end of the presentation. Thank you for watching and listening.